In today's video we're going to talk about the different ways of showing chemical structures. So the first one is a general formula, the second one will be the displayed formula in 2 dimensions and 3 dimensions, the third one will be the structural formula, and the fourth one will be the skeletal formula. So these two you would have met at GCSE, and these two, coupled with the third dimension here, is something that you'll cover A level or equivalent. So if we start with the general formula, like I said, you would have met this at GCSE, and it simply shows the number of each atom. So if we just go through 2 quick examples to demonstrate what this is. So methanol has 1 carbon, meth, an OH group, and 3 hydrogens. So one way to show this would be simply to say CH3OH. So you see 1 carbon, 3 hydrogens, and then an OH hydroxy group on there. And that's all the general formula is just CH3OH. It's just showing the number of each atom present. So butane, as you know, butane has 4 carbons, 3 hydrogens on the 2 end ones, and 2 hydrogens on the 2 central carbons. So how would we show this with general formula? Again, it's just simply the number of atoms. So as we've got 4 carbons, C4, and H10. So you either count 4, 4, and 2, which makes 10, or you can use the formula where it's for a hydrocarbon alkane, where it's CnH2n plus 2. So the general formula for butane will be C4H10. You'll be able to find many examples online that you can practice if you wish, but again, you would have met this one at GCSE, so you've probably had a fair bit of practice already. So the next one is the displayed formula. This shows, or as I like to say, displays, this is how I remember it, the structure and position of each atom. So you may have seen me do it before in the previous slides, but methanol, if you remember, meth has 1 carbon, and 3 hydrogens, and 1 OH group. So that's methanol in the 2 dimensions, and this is what the displayed formula is. It's just simply drawing out what you see, or like I said, how I remember it, just displaying what the molecule looks like. So for example, you saw butane earlier, you could have propane, which would be 3 carbons, prop, and you'd have the hydrogens attached to those carbons. And all you're doing is displaying the formula. And again, you would have used this a lot at GCSE. You may not know that it was called a displayed formula, but you would have used it a lot at GCSE. So a second example, but this time I'm going to do it in the 3rd dimension, and that just makes it a bit more complicated, but it's pretty simple to pick up. So when we look at bonds, you typically draw as straight lines here, and when you're doing it in 3 dimensions, this means it's in the plane. But you also have 2 other bonds, which are called dashes and wedges. So dashes means it's going into the plane, and the wedges means it's coming out of the plane, so coming towards you. So if we were to draw chloromethane, if I do it in the 2 dimensions first, just to show you what it would look like. So again, methane has 1 carbon, chloro means it has a chlorine, and ane means it's an alkane, so the rest are just simple hydrogens. How we would draw this in 3 dimensions would be central carbon. You can pick whichever atom you want to go where, because it doesn't specify here. Chlorine. You would have 2 atoms coming in with the plane. You would then have 1 atom going into the plane, and 1 atom coming out of the plane. And why is it like that? Why is it a tetrahedral shape? As you can see, you've got here, this would form a tetrahedral if you're looking in the 3 dimensions, and that's because this angle between 2 bonds is 109.5 degrees. And that's how you get a tetrahedral. And the reason why you get to 109.5 degrees is because electrons in the bonds are repelling each other, and this is how you get the maximum angle, so you have the least repulsion. So for example, if these three hydrogens were pushed together at, say, 90 degrees, there's going to be a lot of repulsion between those lone pairs, so they're going to spread out as much as they can. And like I said, it comes to 109.5 degrees in this case. So if we go on to the next one, we're looking at the structural formula. So this is one that you're going to meet at A-level again and use a fair bit. So it shows the position of each group of atoms without having to draw the structure. So if I do the displayed formula from earlier for 2-chloropropane-1-ol, we've got prop, so that's C3. On carbon 1 we have an OH. On carbon 2 we have a Cl, denoted by the 2 and the 1 respectively. And the rest as it's propan, which says alkane, we just have hydrogens. So the structural formula is basically writing this out, and we don't have to draw it. So the best way to show this is just to actually show this. So it would be CH2OH. You look at the first carbon, you always start with the carbon, so C. We've got two hydrogens attached to it and an OH, so CH2OH. We've got the second carbon, which is CHCl. See, we've got a hydrogen and a chlorine on there. And then CH3. See, we've got a carbon with 3 hydrogens on there. So you're just simply writing out what you see, and it's quicker than having to draw out this displayed formula, but it gives you more information than a general formula, which in this case would be C3H3456 ClOH. That doesn't show you anything at all. It doesn't show you where the OH is, it doesn't show you where the Cl is, because the OH could be on carbon 1, could be carbon 2, Cl could be carbon 1, 2, 3, it could be anywhere, and that formula there is not very helpful because it doesn't show you where anything is. Whereas this one here, the structural formula, shows you exactly where everything is, and it makes it easy for, if you want to draw it out, you can. So if we go on to a second example, feel free to pause the video at any point just to have a go yourself before I go through it, and then I'll show you after. So, example 2. So 2-methylpropane. So if we start with 3 carbons from the prop here, and then there's a methyl group coming off carbon 2, which methyl is 1, so on carbon 2 we have 1 coming off there, and CH3 here, got a hydrogen on here, 3 hydrogens on here, and again you've got your 3 hydrogens off this methyl group. So like I said before, I'm just going to draw out the displayed formula just to make it easier for you to see what's happening. So now if we do the structure formula, if we start with the first carbon, it's CH3 here, and on the second carbon we've got CH, but now here's where there's a key difference. You do a bracket to represent this methyl, put CH3, and then the final CH3 there. And the reason why we put the bracket is to note that it's that whole group that comes off that carbon. Over here on this first example, that's actually attached to that carbon, that's not coming off on its own group, that's just like one atom coming off, and OH, everyone knows that it's an OH group, so we can just put OH. It's not where you've got a carbon and 3 hydrogens, so you denote it by a bracket. For example, if off that middle carbon there you had CH2, CH2, Cl, you would actually put a bracket around there to show that it's that whole group coming off. Because if you just put it around the CH2, you'd think, oh, the next bit in the chain is CH2, then a Cl here, but it's actually not. You need to put a bracket to denote that it's coming off a carbon. So, if I was to do another quick example, which I haven't written down here, with that group there, if we replaced this methyl group with the one that I've put just here, I'll just write it out quickly for you. So that would be CH3, again starting with the first carbon with 3 hydrogens, then we'd have CH, then we'd have bracket CH3, 2 CH2 Cl, and then the final CH3. However, now this is where the next lesson comes in. That's actually incorrect. And the reason for that is you always look for the longest chain hydrocarbon before you put the brackets in. So in fact, that CH3 there should be in brackets and these shouldn't, because the longest chain is 1, 2, 3, 4 carbons long. Whereas if we go 1, 2, 3 down here, that's not the longest chain. So in fact, the actual thing would be CH3, CH, bracket CH3, and then the CH2, that group there, CH2, CH2Cl. And again, the reason for that is because you always take the longest chain to be your backbone, and the shorter chain is the one that comes off. So, if we now go on to the skeletal formula, and this is the one that chemists always use as it's the quickest way of showing a structure, because you don't have to write all the carbons and all the hydrogens. So how you show this is a line like this represents a carbon here and a carbon here. If you had two lines, carbon here, carbon here, carbon here. Just like you would write C, C like that. One line shows two carbons with a bond in between. But instead, you don't have to write the C. You just draw a line. So that's just the same as drawing that. You don't have to write those carbons in, and that saves time. Neither do you have to write those hydrogens, because you would have two hydrogens on here. And actually, with the skeletal formula, it replaces the carbons and the hydrogens. So when you see a single bond, you just assume there's hydrogens coming off here. So if this was ethane, for example, that indicates a CH3, that indicates a CH3. And all we've just done is drawn a line rather than having to write 3, 6, 7, 8 different letters down. So if we take the first example that I've done here is octane. So it's 8 carbons long, and because it's ane, octane, it just means there's just hydrogens as it's an alkane. So there's nothing else, we don't have to worry about anything else. So we go 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8 carbons. As simple as that. You don't put the dots in, you literally just draw the lines. I just put the dots up here and click there to count, purely just to show you that there is a carbon there at each point. At each point where the lines join, or at the end of each one, represents a carbon and the relevant hydrogens. So, cyclohexane, if we try that, ane, again, means there's just hydrogens, nothing else. Hex means 6, and cyclo means it's in a ring. So, a ring of 6 carbons and nothing else. So, we go 1, 2, 3, 4. So 6. 1, 2, 3, 4, 5, 6. So just again, I'll draw that out. 1, 2, 3, 4, 5, 6, and you just join it back up because it's cyclo. So 1, 2, 3, 4, 5, 6. Shows your 6 carbons, cyclohexane. So if I just show you a few more examples of that with some functional groups such as OH or a chlorine or something like that. So if we had chloroethane, we're going to have the 2 carbons. This is the displayed formula. We're going to have the hydrogen, hydrogen, and the 3 hydrogens coming off here. Now if we wanted to do that in the skeletal formula, we'd simply have carbon to carbon, so you don't show the carbons or the hydrogens, but you then have a second line showing the chlorine. So here this represents CH3, just like that one there. This represents CH3, however, there's a chlorine instead, so actually it's CH2. So you just have to remember, if there's nothing bonded to it, it's a CH3. If there's something coming off, such as a chlorine or an OH, it'd be CH2 and whatever's coming off. Or if there was a double bond, which I'm about to show you, would represent an alkene. So if we did ethene, it would be 2 carbons, but because it's ene, it's an alkene, you have a double bond there. Simply do 2 lines, because there's meant to be a carbon there and a carbon there, which ethene in the displayed formula would be C double bond C, and the hydrogen is coming off. And that just shows that. Nice and simple, really quick. You saw how long it took me to draw that, and you've seen how long it takes me to draw that, and that's a lot quicker. So, if I draw out a new structure, if I just put a line separating them there, I would like you to pause the video and have a go yourself once I've drawn it, and see if you can do it using the principles I've just taught you. Okay, if you've just unpaused the video, I'm now about to write the answer in the skeletal formula. So we start with carbon 1, there's 3 carbons, so we can go 1, 2, 3. I'm just going to redo that as the pen went a bit funny then. So we go 1, 2, 3. 1, 2, 3 carbons. So first carbon here, just CH3. So we leave that alone. That's not a problem at all. So here, carbon has 4 bonds. So we've got 1 to carbon, 1 to carbon, that's 2 left. We've got a hydrogen, and you would expect another hydrogen there. However, instead of one of the hydrogens, it's got NH2. So you just write that up there, NH2. Okay, now we move on to the third carbon. We've got a hydrogen, a chlorine, and an oxygen. So here at the moment it represents CH3, but we want to put a chlorine on. So for chlorine, now this is representing CH2Cl, which we don't want. We want CHOHCl. So all we do is just put an OH here. So now this is the skeletal formula for this displayed structure here. So CH3, CH, NH2, COH, Cl, and the other hydrogen, which we don't write in there. Now that's as simple as it is. It's nice and quick, and chemists use it in organic chemistry all the time because it really is simple to use and nice and quick. And all you've got to do is just have a go, Google some practice questions online, or write to me and I'll make another video with more examples. And yeah, it's nice and simple like that. So hopefully this video's helped. Please like and subscribe for more chemistry videos, and look at my other videos that are on there currently. If you would like me to make a video on something that I haven't covered already, just write in the comments below or send me a message and I'll do one as quick as I can. Thank you.